How's it going, everybody? What we're going to do is today we're going to look at similar proportions and similar figures. So I'm actually combining two lessons that I typically do with the kids. I feel like they relate so much that I'm just going to do it all in one video. So we're going to look at similar proportions, which is really just straightforward computation. And then we're going to look how it applies to similar figures, all right? With that, you'll see like some real world approaches, but it's more along the lines of geometry, which at one point you're going to probably, most kids take a full year of that in high school at some point. So I hope that you find that it's helpful. Please leave a comment below, subscribe, share, all that will help me out. Thanks. All right, so what they want us to do here is to determine if these ratios are proportional, all right? One of the things that I need to clarify with ratio is that they can be written as fractions. They look like fractions, but we don't read them as a fraction. Like, so for instance, with this, normally we would read that as 3/4, but it's not read as 3/4 when it's a ratio. It's 3 to 4. So what does that mean? Well, in real world terms, let's say that the 3 represents boys, the 4 represents girls. So we have a 3 to 4 boy to girl ratio. So you may also see it written like this, with a colon in the middle, and on the rare occasion you may see written as words. All right, all those are considered to be ratios. Okay, so what we're going to do now is to look to see if they're actually proportional. All right, so it says that it's equal right now, but we're going to see if that's true. You have one of two ways to do this. So the easiest is to look and see, can I multiply the top or bottom number by something to get to this number here on the right? So, well, 3 can go into 24 8 times, so that needs to work on the bottom for this to be proportional. 8 times 3 is 24, 8 times 4 is 32. So with that being said, we know that it's a yes, all right? But in some cases, we may not be able to use that, so we'll use what's called the butterfly method, all right? This is probably the foolproof way to do it, and when we have to solve proportions, you have to go this way. So 4 times 24 is 96. 32 times 3 is 96, so we end up with the same number, so this would be yes, they are proportional. Now with this second one here, 6 to 14 is equal to 15 to 35. There's not anything that I can see right off the bat that I can multiply 6 by to get 15 or 14 by anything to get 35. That doesn't mean that necessarily it is not proportional. So if that's the case, we're just going to go ahead and do our cross products, our butterfly method. All right, you don't just want to stop and say no. So 14 times 15 is 210. 6 times 35 is 210 as well. So actually, this is a yes. All right, so you got to be careful there. It actually is a yes. All right, with this one, well, we'll go back to our way with multiplication. So if the top doesn't work, you can go to the bottom. It doesn't matter where you start. 7 times 6 will get us 42. If we try that on the bottom, well, 11 times 6 is 66, not 60, so this is a no. All right, so that works. All right, what we're going to do now is determine whether or not that these two triangles on top and for the bottom, if they're similar. All right, so if you look here, the smaller triangle, it looks like it's a shrunken version of the large one. I always tell my kids, don't ever trust the drawings, whether it's a worksheet printed out. All right, so we actually have to do the math to figure out if they're proportional. So it's a 3-sided figure, it's a triangle, so we're going to write 3 different proportions. All right, now when you start out, you can go from the larger to the smaller, smaller to the larger, so you have some freedom of what number you're going to pick. So I'm just going to go make it more streamlined, the 2. All right, so if I pick the 2 from the smaller, I want to see which one it'll match up with the larger. All right, since 2 is the smallest of the 3 numbers here with the triangle, 6 is the smallest of the triangle here, because in some cases they're not going to be set up where like they're just moved over. They might be flipped, they might be upside down, so you want to be careful there. All right, next one, I can pick the 6 or the 7. Let's go with the 6. That's our middle number. 12 is the middle number there, and then we have 7 going with the 14. All right, now we want to see if these are proportional. Okay, so what we're going to do is we're going to try and reduce these. I know that they're not fractions, but we'll see if we can reduce them down. And we have to have a match for all 3 for them to be proportional. All right, as soon as we don't have a match, boom, done. They're not similar. So 2 over 6, that could be reduced to 1 over 3. 6 over 12 reduces to 1 over 2, or 1 to 2, and the last one reduces to 1 over 2. Since this does not match the others, this is a big no. They are not similar. All right, with the bottom one, all right, this is an example where our other figure, our other triangle is slightly distorted or sideways. So rather than try and match them up, go with smaller to smaller, middle to middle, larger to larger, and so on, whatever the event is. All right, so we'll start with the smaller triangle again. 13, that's the smallest number of that set. And that'll match up with 16, okay? We'll go with 15, that's the middle number. That matches up with our 20. All right, 16 matches up with our 21. And let's see, this cannot be reduced, this cannot be reduced. All right, already, they're in lowest terms, although this can be reduced to 3/4 or 3/4. We have no matches here. So this is also a no. Okay. All right, now with these parallelograms, we're going to look to see if they are similar. So most students will look right at the edges and see that the edges all say that they're 7. So the corresponding sides, right, since they're all 7, would give us that it's a yes. But we also have our corresponding angles here, all right? We always go to the angles first. The other examples we had didn't give us the angles, so we can't compare something that we don't have. Now with this, look, 180, 180, okay? 110, 70. So none of them match. This has to be, the angles have to be exactly alike. So this one is slightly off to the side a bit. So this is a no. And the reason is angles are not corresponding. Are not similar, I'm sorry. Angles are not similar. All right. So yes, they all equal 360, which we've talked about before, but they are not similar. All right, so that is our lesson on similar proportions and similar figures. You can see that if you're setting them up as ratios, or we look at them as fractions in some cases, but we don't really read them as fractions. Another thing I should mention is that when you're looking at ratios, it's okay to have your top number larger than the bottom, because like I said, it's not considered to be a fraction, so it would not be improper. So for instance, if you have 5 dogs for every 3 cats, it would be 5 to 3, and it's fine to leave it like that. Make sure that you're using the cross products. You can also use that multiplication method that we talked about. The cross products will be more helpful, I believe, because it's foolproof. You can't go wrong with that. And further on, where we're going to look at solving for similar figures and proportions, that is the only method that will really work. So it's probably better to practice that. All right. Please make sure that you leave a comment if you find it helpful, or if there's something else that you'd like me to do. Otherwise, have a great day. You may want to rewatch it a few times to get the gist of it, but as long as you're organized, you should be okay.